Hello, everyone, and welcome to Lab Talk number 28. I'm Brian Tristan Williams, and today we're diving into the world of RISC-V, the open source architecture that's revolutionizing embedded development. Joining me is Elector Editor-in-Chief Jens Nickel, and we are thrilled to explore how RISC-V is shaping the future of IoT, AI, and beyond. How are you, Jens?
I'm fine, thank you, and hello to the audience.
Great. Also joining us are Elector engineers Saad Imtiaz and Jean-François Simon. You guys good?
Hi, Brian.
Hello.
Okay, so we have the Brain Trust in the house, and now to our special guest, Vincent Defer. And I've had 2 weeks to learn how to pronounce that. I hope I'm getting it right. Vincent is an experienced IT trainer and former full-stack developer with nearly 30 years in the industry. He's passionate about open source software with significant contributions to FreeBSD, Linux, and now RISC-V. He also creates articles, courses, and exercises to make RISC-V accessible to students, developers, and hobbyists. Vincent, welcome. Vincent. Let me tell you about our giveaway before we go on. Yes, as you see, 3 lucky viewers will win a bundle consisting of the book RISC-V Assembly Language Programming using ESP32C3 and QEMU, and an ESP32C3 DevKit M1 development board, which is the perfect way to start exploring RISC-V hands-on. So stay tuned for details on how to enter. If you're a regular viewer, you know I'll give the code word later. And before we go on, let's have a look at our sponsor. I'd like to take a moment to tell you about EE News Europe. If you are looking for the latest electronics and engineering news, check out EENewsEurope.com, which is an Elector International Media publication. EE News Europe is a fully digital publication covering the global electronics market with specializations in analog, automotive, embedded, power, smart 2.0, and wireless technologies. So read EENewsEurope.com and subscribe to its newsletters to stay informed about essential industry news, key events, and technological innovations. That's EENewsEurope.com. So now, let's move on with the show. I'll start off with Jens because he was quite excited about this topic when we first started discussing it. Jens, what made you so interested in RISC-V development?
Yeah, of course, I'm always interested in processors and software and so on. So that is my typical domain. And yeah, I think I've heard about RISC-V for the first time, let's say 6 or 7 years ago. That was our former senior engineer, Matthias, who said, okay, there's a really exciting technology and we should report on that. And then I thought, okay, RISC-V, of course, I knew RISC processors. But then, yeah, I started to dive in and I was really thrilled by that technology because, yeah, it's an open source ISA set. And yeah, I also like the modularity of that and that so many companies are working together that it is, we can maybe come later to that, in some form compatible. So in principle, you could work with one compiler for many different processors and so on. And yeah, it's really a nice technology. And yeah, on top, there comes that there are really cheap processors, really quite cheap microcontrollers and microcontroller boards. Maybe we can come later to this again.
Yeah, and taking a look at Vincent's website here, I've translated it to English just using the Google Translate. You have a lot of information here, Vincent, and I see a lot of people programming in C. So like Jens said, the compilers are compatible across different platforms. But have you done much programming in assembly on RISC-V platforms?
No, I'm just limiting myself to the startup routine because I don't really need, well, nobody really needs to use, except in very specific situations, nobody really needs to use assembly these days, except for very critical subroutines that need to to be very efficient. But that's all. All the rest is fully portable. It's good.
And Saad and Jean-Francois have recently done an article about RISC-V. Have you guys done much programming on the platforms? I know I haven't started yet.
Well, speaking of RISC-V, well, I've been using ESP32, C3, ES3, all are RISC-V, of course, but I'm using it with Arduino IDE, not even ESP IDF. So it's not like I'm changing or using some different type of approach or trying to figure out scrolling through data sheets to make it work. It's a seamless step into it. So it doesn't really affect programming in that case. But the thing which is good about RISC-V is the modularity of RISC-V is it allows the designers to include the only features they need inside the chip, the SoC, so they can start minimizing power consumption and maximizing efficiency. Yeah, just if you don't need a module or you don't need that specific case for that type of a chip, you simply just don't use it. And that's what's good about this technology or architecture.
Yeah, so it's a whole change in architecture. And I guess the reason I ask about assembly, even though Alphonse right, you don't really need to program in assembly these days. But I heard about RISC back in the 80s, and the whole thing was the reduced size of the instruction set. So I'm interested in that, and I've got a RISC-V book on bare metal programming in assembly, but not necessary. Vincent, what are your primary applications for this, and what made you so interested in RISC-V? Because, like I said, you've been contributing to FreeBSD and so on, but RISC-V is really something where you've done a heck of a lot looking at your website.
My primary education is in electronics, and in my young days, I've had fun with Elector's Junior Computer, and so at some point I went back to my roots as a hobby, and I've discovered what all everybody was doing with Arduino, and I've realized that people using Arduino didn't really understand what they were doing, and they were just copy-pasting code from everywhere, and they went into problems they couldn't solve by themselves. So I decided to create a website to explain in detail the basics of microcontrollers, so people could use the real tools, real professional tools, and understand what we are doing.
And do you have a large following of people visiting your website? I know that it being French maybe limits the audience a little bit, but nowadays translations are easy enough.
Unfortunately, I don't have web statistics. It's something I haven't cared about so far, but it's a good suggestion.
Yeah, no, not necessarily just your website statistics, but the number of people who interact with you, whether it be on your website or in forums, because you are kind of the RISC-V expert for us.
Very few people, 2 or 3, not more.
Okay.
I guess there are more who use my site, but they don't reach out.
And in terms of the market share, as I said, it's taking on ARM. How big is it getting?
It's very difficult to tell, because billions of RISC-V cores ship every year, but they are most of the time included in very big SoC, and they are supervision cores or auxiliary cores. So you can't just count the sales of PCs to know to determine the success of RISC-V. It's deeply embedded in SoCs. Even Apple uses them. So every time Mac ships, there are a bunch of RISC-V cores inside, even though if the main processor is ARM.
Yeah, even the Raspberry Pi Pico 2 has a RISC-V option in there inside the system.
Yeah.
So it does seem to be growing.
There are also many. Yes.
No, sorry. Go ahead.
There are so many ARM chips that have an auxiliary RISC-V core, mainly from Rockchip, the RV 1103 and 1106. It's a measure of the success of RISC-V because even ARM houses feel the need to put RISC-V on their docks.
I see. Talking about RISC, there are in RISC, so that means reduced instruction set. I think at RISC-V, concerning the core capabilities, that's even more reduced than, for example, for the other platforms. What is the minimum amount of instructions you have to implement?
The minimal extension RV32i is something like 50 instructions, but you could even, if you code in assembly yourself, you could even create a RISC-V processor with only 37 instructions, because you can emulate some of the 50 instructions.
I see.
So
then it gets slightly slower because it uses more cycles. Okay. And then the different companies, they can also extend that instruction set. So is that common that companies who are building cores have proprietary extensions of that instruction set?
It's quite common, yes, because they want to push their SoC ahead, so they add improvements. But what is interesting with RISC-V is that proprietary extensions have been allowed from the very start. There are code ranges that are reserved for proprietary extensions. So it's very well designed from the start.
Okay, but then you lose, of course, the compatibility concerning the compiler, because then you have to have a compiler which are using these proprietary extensions.
Yes, but so what happens is those chip manufacturers customize GCC or C-Lang version, and then if their extension proves successful, they upstream their extensions, so those extensions get included as options in C-Lang and GCC.
And do they publish all the details about these extensions, or is that okay?
Yeah.
So everybody can use the extensions, or could also implement these, or are there license costs then?
Usually, well, yes, there are C5's cores stick to to RISC-V standards, but third-party cores such as T-heads bring custom extensions. So it's and you can license their cores. It's an IP house. T-head.
You can license the core.
Yes.
But
So
I think there are also cores which are completely open source. Also, so not only the ISA, which is always open source, also the implementation.
yes.
Can you say something about that?
There have been originally RISC-V was developed for universities in the US, and so those universities have open sourced the cores they were working on with their students, and now the industry goes into open source with T-head, who has open sourced 2 of their cores, and now the Chinese Academy of Sciences, who develops data center grade core and open sources it. So it's very impressive.
Okay. But on the other hand, I think there are a lot of Chinese players on the market. So not only for the cores, also for the controllers, which also integrates then peripheral elements and so on. And yeah, we can also see a lot of boards coming from Far East. How difficult is it to get the documentation about these controllers, or what is your experience? Are all these compilers, for example, IDEs, and all the details, are they well documented, or what is the situation?
Microcontrollers from Espressif are pretty well documented and very well supported. There's a development framework that is called ESP-IDF, and the level of quality is very high. Another well-known competitor to Espressif is Buffalo Labs, and they have good English documentation, but their software support is it's terrible. And there's also WCH, who has good quality English documentation, an IDE based on Visual Studio Code, and a comprehensive range of RISC-V processors, microcontrollers. It's very interesting, very easy to use, and you can contact WCH directly, even if you're a hobbyist. If you have a serious question, they will answer you, and that's remarkable.
Yeah. WCH is an interesting player because they have very cheap controllers and very cheap boards. There is even a processor, I think, or MCU SoC for about 10 cents available.
Yes.
Which is, of course, remarkable for a 32-bit processor. And yeah, I can already announce that we will have in one of the next editions a hands-on article from our regular author Tam Hanna, who is programming that processor with that IDE. Do you have own experiences with that IDE, also?
I use it. I use the former version of the IDE, in my course. So it's entirely built on the CH32V003 and WCH IDE. And I particularly like WCH product range because they have very capable chips. And the CH32V307, for instance, is a very capable chip with many more IOs than expressives, but no radio. So
Okay.
And yes, you mentioned Buffalo Labs, and I knew I had seen that somewhere. We've only once posted an article with Buffalo Lab, from what I could find. And
That
You
was
say
for
the-
Matthias, yes.
yeah, from Matthias Clausen. Clausen. You say the documentation there is terrible.
documentation is correct, but their SDK is a complete wreck. The only decently supported chip is the BL616 and 618, but the other chips are poorly supported, and it's a pity.
Cool. And aside from our questions, let's get interactive here and just welcome our audience. Frank de Hat from Velen, Belgium is here. And hello to Ichong Ayong from Amsterdam as well. And Jack, eEngineer04, looking forward to the RISC-V topic. So welcome everyone from around the world as always. Now let's get to some questions. Okay, there's a comment, not a question. Tronics Hack says assembly is important for debugging and also reverse engineering. Yeah, but as Vincent was saying earlier, if you are starting off on Arduino and copying and pasting, I don't think debugging and reverse engineering is top of your list yet. And Frank de Hat says he also had some fun with the junior computer from Elector. Here's a question from Annie T. Welcome again, Annie T. Do you guys actively seek out RISC-V, or do you go with cheaper solutions, or do you each prefer ARM? Basically, how do you decide?
Who want to answer?
Yeah, we have to
I'll
choose someone to
I'll
answer.
start then.
Yes.
I'll start with, from my side, I specifically don't prefer, as in I have not a go-to chip. Let's say I'll just use Arduino or Arduino line microcontrollers, or let's say microcontrollers from ESP. But mostly it depends upon the application. So most of the time I'm going for IoT, Wi-Fi, of course, Bluetooth. So the go-to is ESP32, and it becomes the most easiest choice because there's so much community support. Everything is good in documentation and everything. On the smaller sides, I used to go for ATtiny, but then now they are so small boards from Xiao, the Xiao line, and it just you don't have any other choice to go for. I mean, that's pretty simple to pick one that up.
So that's
If
how
the-
you choose.
If the IO lines are enough, you have to say. I also
Yeah,
like the
that's true.
Flow.
That's very true.
If you need a lot of IO lines, then it's too small. Yeah, I also would like to say that we, when we want to develop applications, we are more driven by, I think, by the peripheral elements and maybe by the specs of the ADC or how many DUCs the controller has or something like that. Not so about the cores, I think. As Saad, as you said, for us it's not so interesting if it's a RISC-V core or an ARM core. Or do you think there are big differences or differences which really are interesting for the application?
There are minimal differences between ARM and RISC-V. What is interesting with RISC-V is that the best experts on the planet have gathered to design something that takes sorry, that takes into account all the lessons learned from the past and try to avoid making the same mistakes and improve on what has been done. And so it's something that has never been done before. Up to now, there were only proprietary designs, and you couldn't contribute to their development. What happens with RISC-V is the same as with Linux. With Linux, Google, Amazon, Microsoft, Oracle, IBM, Meta have joined their forces to develop the foundation of the internet. And the same happens today with RISC-V. So it's not really visible when you use microcontrollers, but on higher end SoCs, expect a lot of good surprises.
Got a question here
Um,
from
yeah.
Jack. He wants to know if any advice for getting started with RISC-V, a course or a specific book. Before I ask anyone to answer, I would say that Ponsard's website is a great starting point. I'll just put there's the URL there. It will be French when you get there the first time, but you can just ask your browser to translate that, I'm sure. And also depends if you want to work top down by starting with a high level language. If you are a novice, perhaps you would start with a high level language and compile that for the chip or maybe even C. But I'm keen on this, which we're giving away, RISC-V assembly language programming, but it is assembly language. But you know that's sort of up my alley from my experience earlier on in programming controllers. And before I ask that question to anyone, while we're here, I may as well give out the code word. I'll make it easy today, and everyone in the chat room can probably guess that, but the code word can be RISC-V. No need for dashes or anything like that, just RISC-V into the giveaway. And just to remind you, let's put that up on screen. electormagazine.com/elector-laptop-giveaway, code word RISC-V. So,
With
Vincent,
or
where
with
would
K?
you... with a spelling error, thank you for spotting that. Let's fix that. In the meantime, can I ask Vincent, where would you tell someone, how could they start up with RISC-V? Good starting point, besides your website, of course, which is great.
The best is to, in my opinion, is to buy a CH32V003 development board, which are very cheap, and download WCH Moonriver Studio and start from here. It's very cheap, it's very easy, and in my opinion, it's the best way to start.
Which board was that? Which board did you say?
The the best way to start is to code. And
Yeah, but which board did you mention?
CH32V003. There are plenty of them on AliExpress, for instance, or many other sites. And so
Great.
So you can very quickly start. And what they made really well is to use the same SDK as ST for the STM32F103, for instance. it has served as a model. So what you will learn with it will be reusable with many other microcontrollers.
Now, that
So
sounded familiar to me. We've got a project on our Electoral Labs platform for a Christmas tree, and they used the CH32V003. You were saying, Jens?
I have a question. Also, you just talked about mistakes which could be avoided because they learn from other architectures. We hear from time to time that processors have vulnerabilities. That's a complicated word. They can fail. There are security issues, gaps, mistakes. Is that also were there also cases at RISC-V? Did they make mistakes which led to security issues and had to correct themselves?
Those are not related to the ISA. The security issues are related to specific implementations.
I see.
So you can't tell it's a flow in RISC-V. It's a flow in a specific SoC.
Okay, so there are never mistakes in the ISA, just in the implementation when they.
Yes, the ISA tries and facilitate the way chips are designed. For instance, RISC-V has made choices in the instruction encoding so that it is very easy to implement it in silicon.
Mhm.
So there are choices that are made in the ISA with this intention, but there's a whole lot of room for design choices in the chip implementation.
And yeah, Vincent has a lot of information on the CH32V003. Again, if you visit his website, you can see the URL up there. DC motors, ultrasonic radio, all sorts of things. So that looks like some fun to play with as well. And what language do you normally program in, Vincent?
I chose to use C for my courses because it's something that is mandatory in the embedded world, and there's nothing wrong with C++, for instance. It's just that when you learn embedded, you really need to learn C.
Yeah, I mean, C, I had a lot of fun with C as well. But then again, I had fun with like 8051 assembly. But yeah, C was very versatile, everything from embedded to making great programs on PCs. And could also access the hardware directly, and you could do just about anything that you could do in assembly. In fact, you could do anything in assembly because you could put some assembly code in the C.
And it's quite worth learning a bit of assembly because it helps you understand so many things. But of course, it's not the best language to develop a full application, but it's quite worth learning.
Yes, C, as I said, was lots of fun. And if you are programming in C on the CH32V003, then I could easily follow along on your website, which I'll put back up there. As I said, it's a French website, but you can use your browser to translate, and there's a lot of great content here. There's the Buffalo Lab microcontrollers that we mentioned earlier, and Vincent also touches on Espressif. It seems like a
I
great.
think there are some people addicted to assembly language because maybe because a few decades ago, when you wanted to get into microcontrollers, basically the only choice was PIC, and there were small PICs, so you'd better be using assembly to get around the limitations inside. But then time has passed, and now we have Arduino, which is a kind of a gold standard that you can easily code in C. The compiler does a great job, and you don't need to suffer with the assembly anymore. And so I hear, Vincent, that you said you were not too enthusiastic about Arduino because then you don't get to know things under the hood, and you don't understand fully what you're doing. So would you suggest using a CH003 instead? And do you think that will replace Arduino for beginners and hobbyists in the future?
No, I think Arduino is still useful to get a foot in embedded because it makes your first steps really easy, and
exactly.
it helps build confidence. But when you begin to feel limited or run into issues that you don't understand, you have to stop Arduino and learn something else.
So that would be more of a second step then. First
Yes.
Arduino, and then to dig more, you can program in C your RISC-V.
Arduino gets you a taste of what it's like to build something and make LEDs blink and make motors turn. So it's pretty good at that job, and so it's quite useful for this. But if you have notions of electronics and programming, then you don't need Arduino. You can directly learn professional tools.
Yeah, I also
and
think it's important to have some rewards when programming and tinkering. If it doesn't work, you have to have things working reasonably quickly, because otherwise you just quit and never touch it again. So, or perhaps it's just me, but I think it can be useful for beginners.
Yeah, as you said, it's not necessary to program in assembly much these days, and it's not that I'm old school, but I feel like learning the assembly of that chip takes me closer to the hardware so that I understand the hardware even better. But yes, for an end application, C is just fine. A question from...
Can you also use that Moonriver Studio to program in assembly, and can you debug on register level, for example, so you really see what's happening?
Yes, you can. You can add .s, an assembly module to your project, and there's at least one, the startup code, which is built along with your project. So there's no problem. You can mix assembly and C, C++.
Question from Gerhard Domanski. What do you think about building your own RISC-V with FPGA? Sounds complicated. What do you think, Vincent?
That's an entirely different world. If you're interested in hardware design, it's definitely something you should do. Yes. But it's very different from using microcontrollers. It's a different fun, but it's fun.
I think there are projects of that kind. It was done, and it's doable. So I think there are FPGA implementations of RISC-V processors.
Yeah, a lot. There are many. I don't have names in mind. There's Rocket Core, ETH in Zurich also has an open source core. There are T-heads. There are many open source cores to deploy on FPGA. So why not build your own? Please do.
I've never played with FPGA, but I have been warned that it does have a steep learning curve, so I'm a bit scared of it. Do any of you guys have FPGA design experience?
I've contemplated using them, but as you said, it's an entirely different beast and another way of thinking, and it's a different world. But it looks very fun too.
Yeah, maybe I should face the challenge and stop being scared of it. But we have so many things that we want to learn.
Yeah.
Saad and Jean-Francois, you guys collaborated on RISC-V material for an upcoming edition. Could you tell us a bit about what you have in store for us? I will start with Saad.
Sure. I'm sorry.
No, let's start with Jean.
Okay.
Yeah, I just wanted to say that indeed we had the opportunity to make a small article about this. And so I first wrote a more generic part about the ecosystem and the why and the how, and in very broad terms. And then Saad got into technical side with a nice list of RISC-V boards and processors that you can use to experiment. So I think that will be a nice article.
Yeah, and I've had a sneak peek, so I can tell you it is a nice article. Saad, what did you put into that?
Well, basically, I just went outside, found a lot of boards which are made on RISC-V architecture. And I can say there are so many options, and we included so less inside the article because, of course, we have a page limit. But there are so many options out there. But the main specific thing which I encountered is I would say, performance. The performance is not up to the mark as an ARM or a desktop grade, but there are some boards which are designed for desktops, like in ATX, micro ATX format, and so on and so forth. Even there were some boards which has onboard NPU, which was really nice to see. And I think we're going to see more and more boards in the coming future based on NPU, as looking at the artificial intelligence and machine learning applications. I think it's now a requirement for any microcontroller in this industrial applications to have an NPU on board, because you're going to have to use machine learning or AI type of processing these days in order to enhance or make them better. So that's the sum of it. But I would like, I cannot name all the boards, but there are so many.
Yeah, well, speaking of upcoming articles, if we go to current articles, just hop on over to our latest magazine. We would be amiss if we didn't just have a look at this. There's the cover: DIY solar energy storage, solar panels. So yeah, this particular edition is focused on the theme of power and energy, and Jens was in agony over it. As he says there, the agony of choice, because there was so much to choose from. There's the table of contents. Now, Editor-in-Chief Jens Nickelt, what interested you in this edition?
Oh, really many things. And yeah, as you said, it was hard to select the projects and background articles. We had so many of them from different authors, and yeah, we had to take the choice at the end. Yeah, our cover story, that's about building your own solar energy storage, a bigger battery system you can use to store energy from solar power plants. And yeah, about that subject, we will have a webinar February the 6th. So that is 8 days from, or 9 days from now. Brian, we both, together with Thomas Scherer, who also did the webinar of last January about balcony power plants, and this time we will talk about solar energy storage, which you can also build yourself. We will talk about how much money you can save, what do you have to consider when you build that, how do you get components and so on. So that's already a very interesting article. And yeah, we have, of course, many projects, circuits. I like the solar module simulator. I think that's really a good idea, a clever circuit, but there are also loads and power banks and so on. So there's plenty of projects.
Yeah, there's a lot to go through here. And if I could just jump ahead to page 22, just a reminder of the STM32 Edge AI contest. STM is sponsoring us and giving us 5,000 euro in prizes. And we're giving out boards to people who can demonstrate a good use case or a good idea for a project. So that you could find in the latest Elector magazine. I'll leave the magazine for there, except I'll go to Saad and Jean-Francois just for a quick, any ideas of what you found to be the most interesting this month?
Personally, the notebook power bank was interesting because I have an old power bank, old laptop, which I want to change the battery, but now I have a solution. So I was reading it. It's quite detailed. So I'm in the process of redesigning the PCB, but keeping the components in order. So it's nice.
It looks interesting. I mean, I've got a couple of notebooks with bad batteries. I'm worried they'll burst into flames one day. Yeah, so I'll definitely check that out. Anything that jumped out to you, Jean-Francois?
Yeah, there are lots of interesting content in this issue indeed, but for me it would be the solar panel simulator. I really like the simulations and curves and measurements.
Yeah, it's one thing I've never considered having to simulate was a solar module. Interesting.
Yeah, if you want to build your own MPP tracker, for example, or yeah, something like that, then that is really interesting. By the way, there is something in the pipeline, so I can already announce that we will have something on a clever design of an MPP tracker, which really will uncover the details.
Awesome. Well, there's your tease, there's your trailer to our audience. It's your reward for watching the show. Let's take another question here from Saldin. What do you think the RISC-V future will look like? Will we see, for example, application in process industry, industrial sensors? I think it's likely that's already happening. Is that right, Vincent?
Yes, this is already happening. What's worth noting is that RISC-V evolves at a very fast pace compared to ARM, for instance. So expect many surprises very quickly because it evolves at a very fast pace. And maybe there's no limit to well, you might not see a lot of desktop applications, but on the server market, it's quite possible that within 5 years you see very interesting things. And also on the smartphone market, maybe. Not in 5 years.
Why do you think it's not interesting for the PC market? Because the competitors are so strong, or what is the...
It's a related question here. Do you think RISC-V will become mainstream as a real competitor to i686? Can we expect a real PC with RISC-V?
We can expect a real PC with RISC-V because there are already some. But I don't think it will challenge Intel in the foreseeable future because of the software. I mean, the applications are built for Intel and Windows. So unless you use Linux, which is very capable, and I've been using Linux for 20 years, and I've never regretted Windows. But unless you use Linux, you will want to stick with Intel.
You want to stick with Intel for if you're using Linux.
If you use Windows, you won't see Windows for RISC-V, so that's certain, because Windows for ARM is just beginning. So the hard part of the job has been done for ARM, so it wouldn't be a huge issue to port it to RISC-V. But imagine the complexity of the job of software publishers that will have to build their applications for Windows on Intel, ARM, RISC-V, Linux on Intel, ARM, RISC-V, Mac. So at some point, you have to reduce the scope of available hardware platforms so that you can work with them. But you don't have the same problem on the server side and on the mobile side, because technology is hidden. It's not on the desktop and laptop markets.
Yeah. I just wanted to bring up a comment here from Tronics Hack. For me, assembly is a good way to figure out how addressing and registers work because you are manipulating them directly. Although, yes, on Arduino, for example, even in C, you have instructions that you can address registers directly, but assembly does take you a little closer to the hardware so you can understand what is actually going there. Because when you go, when you write to a pin in Arduino C, you're not really aware that that's happening via a register. Anyway,
And it's faster. So when if you're toggling pins and you want to toggle pins as fast as possible with Arduino IDE, you can use C and assembly at the same time, which significantly changes the speed of
Exactly.
toggling normal stuff.
An interesting comment here. Does it not depend on the instruction set? x86 has a full set and RISC-V can be scaled. I'm no expert, but I think you can do as much with the reduced instruction set as a bigger instruction. You just use more instructions. I don't know if I'm explaining that clearly, but it takes a lot more assembly instructions, for example, to do a C function. So if I'm and clarify what I'm trying to say, or what I'm trying to ask is, the RISC-V instructions can simulate any instruction set processors, isn't that right?
In fact, Intel and ARM processors come with a full instruction set. With RISC-V, it's modular. But the problem is how do you deal with this modularity? So the RISC-V work groups have come up with RISC-V profiles, which define, for instance, for PC application, what are the required extensions and what are optional or recommended additions to that basic set. So this means that you have, through RISC-V profiles, you have the equivalent of the Intel and ARM instruction sets. But so profiles make it easy to deal with this equivalence. But for very deeply embedded RISC-V calls, you retain the ability to customize, to use only a minimal set of extensions to save on silicon space or power, etc.
Interesting question. When programming with the Arduino framework, is there a difference programming, let's say, a regular ESP32 versus a new RISC-V S3? I don't know, but I know the ESP32C3 that we're giving away today is RISC-V and can be programmed with the Arduino, if I'm not mistaken, Arduino IDE. Do you have any experience with that, Vincent?
No, I've not used the Arduino environment.
I think if
Okay.
you stick to the usual commands and libraries, I think there's no difference. So you will not see it. Of course,
Exactly.
you see the number of the cores. That is interesting. The number of, for example, if you have I2S units, it's of course a different. If you just have one or two, and such things, you see the size of the memory and so on. But I think if the core is implemented as a RISC-V or as an ARM or extensor, I don't think you see it.
Yeah, there is a small thing, is that if you're using the basic I/O manipulation, using the Wi-Fi, getting the data, that's okay. But some libraries are specifically optimized for the extensa-based ESP32.
Okay.
So you might face some difficulty using that same library on the RISC-V chips, but it's still pretty usable. I didn't. Well, I had to change the library, and it was still working. But there's some small hiccups here and there, but they're not like majority. 90% of the time, you won't even feel that you're using a different ESP32.
Great. Well, that's been some great information, but unfortunately we've gone over time already. I hate it when that happens. It's an interesting conversation, but I'm definitely interested in diving more into RISC-V. So let's have a look at what we can do there. And thanks for your article, Jean-Francois and Saad on RISC-V. It was a good dive in, even though we've been covering RISC-V for a while now. It's really starting to get momentum now. I guess when I paid the most attention was when Raspberry Pi decided to release a chip with RISC-V cores on it. So yeah, I think it's becoming mainstream enough to take a closer look. Thank you, Vincent, for joining us. You are a wealth of expertise, and I would recommend to everyone to visit his website. I mean, look how much is going on there. There's so much to choose from. And I need to get one of those Tencent micros, the CS32V003, so I can do some experiments myself. Let's put the banner up on the screen. There you have it. So visit Vincent's site. Please don't crash it. Let's go slowly, people. And thanks to everyone who's joining us in the chat. Special thanks to our new member, Ovasmile. I'm not sure if I'm pronouncing that correctly, but we've got a new YouTube member on YouTube. And speaking of YouTube, I would like to talk about our upcoming shows. So tomorrow, January 29th at 16 hours CET, we will have Every Flavor of Robot on Electrical Engineering Insights. And then on Thursday, we've got a great webinar with Anand Gupta from Espressif, which will be about the ESP32P4. So if you could if you could join us for that, that would be great. I'm just looking at some of the comments. Some of you are funny, but I won't put them up on screen. And thanks to everyone for joining us from around the world. Once again, thanks to Vincent. Visit his website. Don't forget to enter our competition. I'm not going to put that back up on the screen because you can rewind this show if you missed anything or if you missed the code word. And if you misspell it with a K, I think we'll accept it because even we make mistakes on spelling sometimes. So thanks to Jens for joining us as well, all the way from Cologne in Germany.
Thank you,
And Saad
Brian.
and Jean-Francois. Saad, it's late for you, so thanks for that as well. And Vincent and Jean-Francois from France. Thanks to our audience. Thanks to everyone. Good night, good afternoon, good evening, wherever you are. Goodbye.
Goodbye.